My name is Nicholas Takach. I'm a professor of chemistry at the University of Tulsa in Tulsa, Oklahoma. We're a small private university, not affiliated with the University of Oklahoma. And I'm going to do a demo today that was not inspired by the book of demos that I have, published by the American Chemical Society. This was actually equipment given to me by a good friend of mine who is my best friend, and he's a former professor at TU. Marwin and his wife Nan were physical chemistry professors at the University of Tulsa, and they left at the same semester I arrived. But then they went on to Amoco and actually made money, and so while they were at Amoco, they were part of a science outreach program called the Science Enrichment Program. And I participated in that as a volunteer. So they wrote a number of hands-on experiments for kids in elementary school to perform. This is one of the more popular demos. Let me explain the props here. I got a sheet of acrylic plastic, a little bit dirty. I've got an aluminum pizza pan, and I have a piece of PVC pipe attached to the pizza pan via double-sided carpet tape. And then I've got paper towels here, and it does make a difference. Recycled paper towels don't work very well at all. So we'll see if taking my shoes off works for part 2. I'm not worried about part 1, but let me explain what I'm going to do. I'm going to rub this acrylic plastic with paper towel. There's electrons are going to accumulate on top of the acrylic plastic. Then I'm going to put this pizza pan on top, and it's by electrical induction, it's going to push the electrons from the bottom of the pizza pan to the top. Then I'm going to touch the pan to drain off the excess charge, and then when I lift it up high like this, it'll become relatively positive, and there'll be a static charge on it. Then my first assistant here she's going to hold this in her left hand, and she's going to turn toward this way. Hold up that object and tell me, what do you see?
These are metals and these are glass.
Okay, what do you see inside the glass? You see anything?
I don't see anything.
Okay. The demonstration or the experiment for kids, you can use a fluorescent light bulb and one that's burned out. It'll still work. So this is a special device made by my friends, and they, after Amoco stopped funding the program after several years, they gave it to me, and you'll see what happens. So you can see nothing. It's just an ordinary glass tube. It's got 2 electrodes. So what I'm going to do is I'm going to charge up, this is called an electrophorus, I don't know why, that's what they call it. But I'm going to do this, rub the acrylic plastic and do everything I said, and then I'm going to lift it up, and you're going to touch this end, or you're going to reach over and touch the end of the pan when I tell you to. And then we'll see what happens. Okay? And maybe in your left hand, so you don't have to cover it. Okay, so let's try this. You don't have to go away. Okay, I'm putting it there. That's a good one. Okay, now touch it with your left hand with the metal. See something? What'd you see? Where did it come from?
Electricity.
Huh? Where do you think it came from? Let's do it again, one more time. And I can tell it's working well. There must be something inside that tube, right? Okay, now, where's my other accomplice? Okay. And what you're going to do is you're going to stand here, you're going to touch this with your right hand, and you're going to hold the other end. You're going to hold, she's going to hold this with her right hand, and then you're going to put your left hand on it, but your right hand has to stay there. Now, instead of touching the pan with the device, you're going to touch it with your hand. Okay? Now, I'm generating a static charge of 10,000 volts. Are you scared? No, you shouldn't. It's 10,000 volts, but it's there's practically no current, so it's perfectly safe. Oh, okay, no, didn't work. Even though none of us are wearing shoes, we don't want to be grounded too much or shielded from. We have to serve as a ground, so the charge is supposed to come up and go through between the two of you. So let's try it one more time. We'll try a different kind of paper. The kind of paper matters. Wool cloth would be really good. Depends on a lot of things like humidity. No, this is called the neon wand. So what you saw was the flash of electrons relaxing. The static charge was enough to excite the electrons to a higher level, and of course they immediately relax. When they relax, they give off light energy, and with neon, one part of the visible spectrum is that orange flash that you saw. So this is a sealed glass tube, and it's got neon inside of it. She had the hypothesis that one of the two, the middle person, should be wearing shoes. So we're going to test that hypothesis to see if it'll flash between them. Did it? No. Okay, one more try. I don't, it might just be the humidities. But I heard a little, when I touch it, you can. Okay, let's do it again.
That was a good one too.
See, this is what the benefit of having students smarter than you are in class. Wow! Very good. You get extra credit for that. Thank you. Thanks for watching, whoever's watching. Oh, I put this on the board last time, might as well do it. That's my email address. If someone wants to have one of these made, I'll talk to my friends and we'll sell you one for a very high price. That's it. Thank you.